guys, what's up? I'm back, trusty whiteboard in hand to help you learn how to graph a quadratic function. So here's the deal. Quadratic functions. It's a fancy sounding word, but all it means is its highest power when you see the equation in front of you is 2. So it's going to be something squared. Maybe that's it. Maybe it's got some other junk behind it, but its highest power is going to be 2. And that's very important because the number 2 almost looks like what the graph looks like. It's more like a U. Okay? A V is an absolute value function. If you see that shape, you know you're dealing with an absolute value equation, but this guy right here is going to be a U shape of some kind. So I will help you by demonstrating a problem start to finish from scratch. Here we go. Let's say we got f of x equals, let's do this, x minus 2 squared, supposed to be a 2 there, minus 3. Okay? And the directions are very simple. We just have to got to graph it, okay? Not that pleasant sounding, especially just one word for the directions, but extremely straightforward once you get used to it, and I'll help you get used to it right now. So, first thing we need is a high quality graph, okay? Some teachers, if they're nice, they'll provide you with graph paper, you know, on your test or whatever. Maybe you got some on your own you can use. If not, you have to draw a graph. It can get kind of nasty. So remember this, the quality of your graph is determined by the quality of your scaling. So here's what that means. That's not even straight at all. So let's try this instead. That's much better. It's not perfect, but it'll do. So we got our x, we got our y. Got to try to scale it right now. So let's see. Put 5 on each axis real quick. See, and you'll notice, yeah, I kind of did this quickly because I'm doing a video, but they're still kind of spaced out well, those tick marks. And that's what you want when you're doing a graph like this. Now, if you know that this is a quadratic function because the high power that you see anywhere is 2, and in this case it's the only power you see, then we know it's going to be a U shape of some kind. So it helps to know the parent function. Now what a parent function is, you guys, is it's just the simplest form of whatever the heck we're talking about. So the simplest form of a power 2 function is just this. I'll call it g of x, which is just another name for a function. Okay? So if I was to graph this, what would it look like? Okay? You should know by now what it looks like. If not, there's a quick way to remind yourself. And all it is you do this. It's a little xy chart. So if x was 0, what would y be? Well, what's 0 squared? It's 0. So 0 goes right here. Then, what would, if I put in 1 here, or if I put in 2, what would my y values be? Because remember, g of x is just another name for a y value. So what's 1 squared? It's 1. What's 2 squared? It's 4. Now, negatives are good to include also. So I'm going to do -1 and -2 as well. So, what is that? Doesn't even look like a -2. There we go, that's better. So what's -1 if I square it? +1. And if I square -2, put it right in there, I get 4. So now look, I got 5 points. And when you graph parabolas, you want to have 5 points, if at all possible. So I'm going to graph this guy right now in blue, because I did it with blue. So I'm going to graph 0, 0, 1, 1, 2, 4, -1, 1, and -2, 4. So here I go. There's 0, 0, there's 1, 1, 2, 4 is right about there. -1, 1, and -2, 4 is right about there. Okay, now I'm going to graph the full thing. Can't just leave the dots there, so here we go. Okay, general U shape. That's all it is. Okay, so now I have to decide, how is this different than this? Pretty straightforward. There's a 2 there, there's a 3 there, with some minuses going on. So you just have to remember that whenever stuff is added onto this, or this is changed or transformed at all, you have to remember what the transformations are, what they look like, and it's very, very straightforward. Anything on the outside, now this 3 with a minus sign is on the outside of the stuff being squared. That's what I mean when I say outside. So anytime you have outside numbers, that means it's a vertical transformation of some kind. And when it's only subtracted or added, it means you're moving it vertically. Okay, anything stuck on the back or stuck in the front that's added or subtracted to the main function, the power 2 part, it's just a vertical movement. Well, down 3, minus 3, that looks good. So I always look at the point on the parent function that's closest to the origin. What happens there? It moves down 3. That means every point on the graph moves down 3. So I'm just going to keep in mind that 0, 0 is going to move down 3 to right there. Okay, I'm going to keep that in mind. So if outside information means vertical transformations, what do you think inside information means? Horizontal transformations. So just like this, if it's added or subtracted, it means it's a movement. However, stuff on the inside, horizontal, is the opposite of what you think. So instead of moving left 2, because left is negative, horizontal direction, we go right 2. Okay? So that means combined, I'm going right 2, I'm going down 3. Right 2, down 3. I'm going to put my point up there. And guess what? Every other point does that exact same series of movements. So this guy goes right 2, down 3. Our negative 1, 1 point goes right 2, down 3. This guy, 1, 1, goes right 2, down 3. And this point 2, 4 goes right 2, down 3. Look what happened. I got a black pattern that looks just like the blue pattern. And now I just got to create my graph. And look, I'm pretty proud of that one actually. That's pretty good looking. Actually, both are not. I wish I could do this all the time. Maybe on video, so I brought it a little bit more here. But you'll notice, same exact shape, the whole entire thing, the blue thing, the parent function. It's like I picked it up, moved it right 2, moved it down 3, and boom, turned into the black guy. So that's all we want to do. That's all we want to do when we have transforming graphs. Hope you found this helpful.